Next topic is compatible system. The solution f x y z p q is equal to 0 number 1 suppose, and g x y z p q is equal to 0 number 2 are compatible on domain D if these two conditions are satisfied. The first one is the Jacobian dava fg dava pq is not equal to 0 on domain D, and the second one is suppose this phi xyz function of xyz, this phi is denoted by small p and this small q is psi xyz, obtaining by solving 1 and 2. Suppose this p and q are obtained from the equation 1 and 2. Solve equation 1 and 2 for p and q. We have the value of p as a function of xyz and value of some q as some function of xyz, suppose psi xyz. So these are the P and Q obtained from equation 1 and 2. Then dz is equal to phi xyz dx plus psi xyz dy, or we can say that dz is equal to, we know that this phi xyz means small p and psi xyz means small q. That is dz is equal to p dx plus q dy is integrable. And we know that when the function is integrable, so this function is integrable. That is, this is the Papian differential equation, and we know that this equation is integrable if x bar dot curl x bar is 0. This is Papian differential equation. This is the differential equation of the form p dx plus q dy plus r dz is equal to 0. So if these two conditions are satisfied by these two solutions 1 and 2, then we say these two solutions are compatible. Okay, so we can obtain note one parameter family of common solution of one parameter family of common solution can be obtained by, this is double, cancel this, one parameter family of common solution can be obtained by solving equation dz is equal to p dx plus q dy. So this is the procedure to obtain the common solution one parameter family by using dz is equal to, by solving this equation dz is equal to p dx plus q dy. This note is useful to obtain the common solution, one parameter family of common solution. That is, we have to solve this differential equation dz is equal to p dx plus q dy. So this is actually the definition of compatible system or compatible solutions. These two are compatible if we have this. Okay, so the next, if these two conditions are satisfied, that is, the Jacobian is not equal to 0 on that domain D, and this equation dz is equal to p dx plus q dy is integrated. So these two conditions, Jacobian is not equal to 0 and dz is equal to p dx plus q dy is integrated. So the necessary and sufficient condition for integrability of dz is equal to p dx plus q dy, that is this equation dz is equal to phi xyz dx plus psi xyz dy, is that this is the notation for this side, that is this dava fg dava xp plus p dava fg dava zp plus dava fg dava yq plus q dava fg dava zq, this is Jacobian, is equal to 0. If this addition is equal to addition of these four quantity equal to 0, then we say this dz is equal to p dx plus q dy is integrable. Is integrable. This equation is integrable if and only if this condition is satisfied. This is equal to 0, and this is denoted by this notation, writing in square bracket f comma g. That is, this is the notation for this. So we have to prove this theorem, and we have to use this theorem for this condition number 2. So how we can check dz is equal to p dx plus q dy is integrable? So we check this value of this addition of these four quantity is equal to 0. Then we say that f and g are this equation dz is equal to p dx plus q dy is integrable. So in order to check whether this f and g are compatible, we have to check dz is equal to p dx plus q dy is integrable. That is, we have to check this is equal to 0. So this is useful in the example. So now we will give the proof of this theorem. So let p is phi xyz and q is psi xyz. Then the given differential equation is the given differential dz is equal to p dx plus q dy. It written in the form dz is equal to phi xyz dx plus psi xyz dy. So p means phi and q means psi, and this p and q are the functions of xyz. So we will write this as phi xyz dx plus psi xyz dy minus dz is equal to 0. This is in the form of p dx plus q dy plus r dz is equal to 0, and is pattern differential equation. What is x bar? X bar means the component of dx, coefficient of dx is phi, and dy is psi, and the coefficient of dz is minus 1. Or we can write phi I plus psi j minus 1 into k. And the given equation 1, this equation is integrable if and only x bar dot curl x bar is 0. We know that the pattern differential equation is integrable when the pattern differential equation is integrable if x bar dot curl x bar is 0 bar is 0. Okay, so now we will find curl x bar. X bar is this. We have to find curl x bar. Curl x bar is determinant I j k dabba dabba x dabba dabba y dabba dabba z, and the components are phi, psi, and minus 1. We have to solve this determinant. I in bracket dabba 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 y of minus 1 is 0, and dabba dabba z of psi is minus psi z. Psi in suffix right z means dabba psi by dabba z minus j. Dabba dabba x of minus 1 is 0, and dabba z of phi is phi z. Suppose phi suffix at right suffix z, that is dabba psi by dabba phi by dabba z plus k. Dabba dabba x of psi means psi x minus dabba dabba y of phi means phi y, and we have that is minus psi z I plus phi minus 1 will become plus phi z j, and this psi x minus phi y k. Now x bar dot curl x bar, that is the dot product. So phi into this minus psi z means minus phi psi z. Then dot product means multiplication of coefficient of I plus multiplication of coefficient of j means psi into phi j plus psi into phi j plus the multiplication of coefficient of k minus 1 into this psi x minus phi y, and that is after simplification we have this minus phi psi z plus phi z minus psi x plus phi y by multiplying by minus 1. And we know that x bar dot curl x bar is 0 if and only if now. So the condition for the integrability is x bar dot curl x bar is 0. So x bar dot curl x bar is 0 if and only if this is equal to 0. That is minus phi psi z psi phi z minus psi z minus phi y is equal to 0. Okay, that is psi phi z plus phi y is equal to, shift this negative quantity to RHS, it is equal to psi z plus psi phi psi z. Okay, psi z plus, after shifting we have this, and in LHS we have psi phi z plus phi y is equal to this. Okay, it is not psi z, it is psi x. This is psi x minus psi x. So right here x psi x plus phi psi z. Okay, so value of this x bar dot curl x bar is this. So right here x, okay, correction at this place x. This is the equation number second. What is the equation number second? Psi phi z plus phi y, psi phi z plus phi y is equal to psi x plus phi psi z. Now consider the equation fxyz pq is equal to 0, where p is phi xyz, q is psi xyz. Differentiating with respect to x and z, we get. So with respect to x derivative, what is the derivative? Fx, that is dabba f by dabba x, plus dabba f by dabba x into, here is dabba f by dabba x by dabba x, and dabba f by dabba y by dabba x is 0. Because x and y are independent variable. X, y, z, now here x, y, z, all these three are independent variable. X, y, z, all are independent variable. This p and q, in the previous topic, this small p means dabba z by dabba x, and this small q means dabba z by dabba y. So here note that in the compatible system, the small p and small q are not dabba z by dabba x and dabba z by dabba y. So all these x, y, z are independent variables, and that is the derivative of x with respect to y or with respect to z is 0. Derivative of y with respect to x and with respect to z is 0. And similarly, the derivative of z with respect to x is 0. Derivative of z with respect to y is 0. So in the previous topics, in all the previous topics, this x and y are independent variables. Z is the function of x and y, and dabba z by dabba x is small p, dabba z by dabba y is small q. But in this example, in this topic, this x, y, z are all these are the independent variables, and p means not dabba z by dabba x, and q means not dabba z by dabba y. So note, before starting this problem topic, write this: small p is not equal to dabba z by dabba x, and small q is not equal to dabba z by dabba. What are p and q? P and q are the functions of x, y, z. Both are functions of x, y, z. It is not dabba z by dabba x and dabba z by dabba y. So the derivative of this f with respect to x is fx plus with respect to this y, derivative of y with respect to x is 0, derivative of z with respect to x is 0. So then this fp into px, that is by using chain rule. Actually, what is the derivative of this function with respect to x is dabba f by dabba x plus dabba x by dabba x is 1 plus dabba f by dabba y by dabba x is 0, and plus dabba z by dabba x, dabba f by dabba z by dabba x is 0, and then dabba f by dabba p, that is fp, dabba p by dabba x means px, plus dabba f by dabba q means fq, dabba q by dabba x is qx is equal to 0. So the complete derivative of this function with respect to x is this, and then derivative with respect to z is dabba f by dabba f by dabba z by dabba x by dabba z is 0. Then dabba f by dabba dabba z by dabba y is 0, and then dabba f by dabba z is fz, and dabba z by dabba z is 1, and dabba f by dabba p, that is fp, dabba p by dabba z is pz, dabba f by dabba q by dabba z is qz is equal to 0. So note that these x, y, z, all these are three are independent variables. Or we have the fx plus fp. This px means p means phi and q means psi. So we have this equation number. Suppose equation number 3 and 4. The given equations are 1 and 2, and then these are the equation number 2 and 3. So multiplying equation 4 by 5 and adding in equation number 3. That is what we have: fx plus phi fz. This addition multiply by 5. So fx plus phi fz. Then fp phi x, fp psi x. So take fp as common. So when we have phi x plus phi z, after addition fp, take fp as common and multiply this by phi. So phi x plus phi z, plus take fq as common. So we have in bracket psi x plus phi psi z is equal to 0. That is multiplying by phi to equation 4 and add in equation number 3, we get this equation number 5. Similarly, from this equation gxyz is equal to 0, differentiate this 6 with respect to, similarly we get differentiate with respect to x and z, and by using this procedure, same procedure, we have gx phi gz plus gp phi x minus phi x plus phi z plus gq psi x plus phi psi z. That is, instead of this f, take gxyzpq is equal to 0, differentiate with respect to x and z, and then multiplying equation 4 by 5 and adding in equation 2. So just replace f by g. We have this from this equation gxyzpq. By using same procedure, we have this. Suppose equation number 6. Then multiplying equation 6 by FP and 5 by GQ, FP and GQ. So multiplying equation 6 by FP and equation 5 by GP and FP, and subtracting, that is cancel this stuff, FP pi x plus pi z. So multiplying equation 6 by FP, that is this quantity FP, and equation 5 by GP. So what do we have? We have this term fx GP multiplying by GP. So fx GP minus gx FP. The next term pi, take phi as common. So we have fz GP minus gz FP. Okay, and this term get cancelled, FP phi x plus phi z, and so multiplying by GP. So FP GP phi x minus plus phi z, and here GP FP phi x plus phi z. So after subtracting, we have this term get 0, and then the next term, from the next term take this psi x plus phi psi z as common. So we have FP GP minus FP FQ GP minus, by multiplying GP, minus this GQ into FP, right? FP into GQ, okay, is equal to 0. So by multiplying 6 by FP and 5 by GP and subtracting, we have this, okay. And this bracket is the DABA FG DABA XP. This is the Jacobian DABA FG DABA XP plus phi. This is the Jacobian DABA FG DABA QP. Write this DABA FG is Jacobian. DABA FG DABA ZQ, this, and then this psi x plus phi psi z as it is, and this bracket is the Jacobian DABA FG DABA QP, not PQ, DABA QP, okay. And then shift this quantity to RHS. We have this phi x plus phi psi z DABA FG DABA QP becomes DABA PQ. Actually this become minus on the right side. This, if you shift this term, then it's minus, and that absorb that minus sign at this place. DABA FG DABA QP, right, the DABA PQ, because DABA, what is the difference between DABA FG DABA QP and DABA FG DABA PQ? That is the difference between sign, that is minus. Actually this term after shifting to RHS become minus and absorb that minus sign at this place. That is right, minus DABA FG DABA QP as plus DABA FG DABA PQ. This is equation number 2. Similarly, differentiate f x y z PQ with respect to y and z. Instead of x and z, here the differentiation with respect to x and z. Instead of that, differentiate with respect to y and z, and we get Fy plus Fp phi y plus Fq psi y is equal to 0. That is the derivative with respect to y is what? DABA f by DABA x by DABA y is 0. DABA f by DABA y means Fy. DABA y by DABA y is 1. DABA f by DABA y, DABA z by DABA y is 0. DABA f by DABA p, DABA f by DABA p into DABA p by DABA y. DABA p by DABA y means phi y, because p means phi. And DABA f by DABA q by DABA y, q means psi y, okay. And with respect to z, derivative is fz plus fp phi z plus fq psi z is equal to 0, again by using the same. And then multiplying equation 9 by psi, and this equation number, and add in 8, multiplying by psi and add in 8. So fy plus psi fz plus fp, take fp as common, phi y plus psi into phi z, take fq as common, psi y plus psi z, psi into psi z, okay, is equal to 0. Similarly, from equation gxyzpq is equal to 0, again differentiate with respect to uh, similarly y and z, and by same procedure we have gy plus psi gz plus gp phi y plus psi phi z plus gq psi y plus psi z is equal to 0. So that is only replace f by g. Multiplying equation 10 by gq, gq, this factor gq, and equation 10 by gq and 11 by fq, 11 by fq. That is, this term get cancelled. This and subtract after subtracting. So we have fy gq minus fq gy plus the next term, this psi, take psi as common. We have fp gq psi as common, fz gq minus gz fq, and then take this term phi y plus psi phi z as common. We have fp gq minus fq gp is equal to 0, because this term gets 0, fq and this gq, and we have this, and then this is fy gq minus fq gy, then just shift this term to RHS, we have this, and then this is a dabba fg dabba yq plus psi dabba fg dabba zq is equal to this phi y plus psi phi z, and this is uh, dabba fg dabba pq, dabba fg dabba pq, this is dabba fg dabba pq. So this minus sign as it is. After shifting this term to RHS, we have minus this term, minus sign as it is, phi y plus psi phi z dabba fg dabba pq, and this is actually phi y minus sign in bracket phi y plus psi phi z into capital J. Capital J means this dabba fg dabba pq. This is 12. So we have from 2 psi phi z plus phi psi y is equal to equation number 2. Again, write the equation number 2. This is the equation number 2. Psi phi z plus phi y is equal to psi x. It is not z, x, psi x plus phi psi z. So write that equation number 2 again. So, and then substitute the value of this phi psi phi z plus phi psi y. Psi phi z plus phi psi y. Equation number 11. Equation number this. Okay, only multiply by j. Then next step is multiply by j Jacobian, that is dabba fg dabba pq, multiply both sides by j, and the value of this quantity phi psi phi z plus phi yj from equation number, this is the equation number 7. The value is this dabba fg dabba xp plus phi dabba fg dabba zq. The value of this quantity psi x plus phi psi z into j is this, is equal to the value of this psi z, psi x plus phi psi z into j. The value is this minus, right? Minus sign. This is the minus. So this is minus. Actually, the minus is shifted to here. Okay. Psi phi j plus phi y, and then it is equal to this dabba fg dabba xp. Yes, phi y. Yes, the value of this quantity is minus of this quantity here. So value of this quantity is minus in bracket dabba fg dabba yq plus psi dabba fg dabba zq. The value of this quantity from equation number 12, and the value of this quantity psi x plus phi psi z into j from equation number 7. It is this dabba fg dabba xp plus phi dabba fg dabba zp. So substitute, and then shift all those terms to these negative terms to RHS and change the LHS and RHS. We have dava FG dava XP this term plus phi dava FG dava ZP plus this term dava FG dava YQ plus this term. After shifting minus, this is minus term. It's become plus dava FG dava ZQ is equal to 0, and this is EFG is equal to 0. That is why to show this condition is equal to 0. Hence theorem. That is, if this is equal to 0, then equation dz is equal to pdx plus q dy is integrable. That is why to show. So this is equal to 0, then the equation dz is equal to pdx plus q dy is integrable. So we will see the examples on this topic in the next lecture, that is show that these two equations are compatible. So how we can show these two equations are compatible? We use the theorem as well as the definition. That is actually we use that, show that the Jacobian is not equal to 0, and then show that dz is equal to pdx plus q dy is integrable. That is, we show this is equal to 0. This addition of four quantity is equal to 0. So we will see the examples in the next lecture.